Picture yourself floating in the depths of space, witnessing a breathtaking cosmic metropolis where thousands of galaxies perform an eternal gravitational dance. Welcome to the Virgo Cluster, one of the most captivating and significant structures in our local universe. This cosmic titan stands as a testament to the grandeur and complexity of our cosmic neighborhood, a celestial city teeming with stellar life and cosmic mysteries. In this vast cosmic ballet, each galaxy moves with precise yet dynamic patterns, bound together by the invisible threads of gravity. Some spiral gracefully like our own Milky Way, while others are massive elliptical behemoths, each containing billions of stars. The Virgo Cluster isn't just a random collection of galaxies. It's a living, breathing cosmic ecosystem that has fascinated astronomers and scientists for centuries. Today, we're embarking on an extraordinary journey to unravel the secrets of this galactic metropolis. We'll discover why the Virgo Cluster holds such a crucial key to understanding our universe's fundamental nature, from its role in galaxy evolution to its influence on the very fabric of space-time itself. But here's something that might send shivers down your spine. At this very moment, as you watch this video, our own Milky Way galaxy is being inexorably pulled toward this colossal city of galaxies by an invisible cosmic force. The Virgo Cluster's gravitational influence reaches across millions of light years, slowly but surely shaping the destiny of our cosmic home. This isn't just distant astronomy. This is the story of our galaxy's future being written in real time across the cosmic canvas. Join me as we dive deep into this astronomical wonder, where each discovery leads to new questions, and every observation reveals another layer of cosmic complexity. Welcome to the Virgo Cluster, where the past, present, and future of our cosmic neighborhood converge in a spectacular display of celestial architecture. If you're as fascinated by these cosmic wonders as I am, make sure to hit that like button and subscribe to Exploring the Universe. Together, we'll continue our journey through the most magnificent phenomena our universe has to offer. Enable those notifications and become part of our growing community of cosmic explorers. The universe is waiting to be discovered, and your next astronomical adventure is just one click away. The Virgo Cluster stands as one of the most remarkable structures in our cosmic vicinity. Let's delve into what makes this celestial marvel truly extraordinary. At its core, the Virgo Cluster represents a massive congregation of galaxies situated within the constellation Virgo. But calling it merely a cluster doesn't do justice to its true magnificence. Imagine a cosmic metropolis sprawling across space, where instead of buildings, we find entire galaxies as its residents. The sheer scale of this celestial gathering is mind-boggling. Within its boundaries, the Virgo Cluster houses between 1,500 and 2,000 galaxies, each one a unique cosmic entity. Think about that for a moment. Each of these galaxies contains billions of stars, and many of these stars host their own planetary systems. The complexity and vastness of this structure challenge our human ability to comprehend its true scale. When we talk about the cluster's location, we're dealing with astronomical distances that stretch the imagination. Situated approximately 54 million light-years from Earth, the Virgo Cluster is practically in our cosmic backyard. To put this in perspective, when the light we're currently observing from the cluster began its journey toward Earth, mammals were just beginning to diversify on our planet after the extinction of the dinosaurs. But perhaps the most fascinating aspect of the Virgo Cluster is its role as the gravitational heart of our local cosmic neighborhood. It serves as the central anchor of the Virgo Supercluster, also known as the local supercluster. This larger structure encompasses not just the Virgo Cluster itself, but also our own local group of galaxies, including the Milky Way and numerous other galaxy groups and clusters. This position makes the Virgo Cluster crucial to our understanding of cosmic structure and evolution. It's like a cosmic city center, where the most dramatic galactic interactions and evolutionary processes play out on a grand scale. The cluster's immense gravitational influence shapes the movement and destiny of thousands of galaxies, including our own Milky Way, which is gradually being drawn toward this massive cosmic hub. Understanding the Virgo Cluster isn't just about satisfying astronomical curiosity. It's about comprehending our own place in the cosmic web and the forces that will shape the future of our galactic home. As we observe and study this magnificent structure, we're not just looking at a distant collection of galaxies. We're looking at a crucial piece of our cosmic neighborhood that holds keys to understanding the evolution and fate of our own galaxy. The story of discovering the Virgo Cluster reads like a cosmic detective novel, spanning centuries of human curiosity and technological advancement. Let's journey through time to understand how this magnificent structure revealed itself to human knowledge. Our story begins in the 18th century with the remarkable French astronomer Charles Messier. In his quest to catalog cosmic objects that might be mistaken for comets, Messier unknowingly documented several of the brightest galaxies in what we now know as the Virgo Cluster. Between 1771 and 1781, he meticulously recorded objects like M49, M60, and the famous M87, though at the time he described them as mysterious nebulae, fuzzy patches in the night sky that his telescopes couldn't resolve clearly. What Messier couldn't have known was that these fuzzy patches were actually entire galaxies, each containing billions of stars. His catalog, however, laid the groundwork for future generations of astronomers to build upon. Throughout the 19th century, as telescope technology improved, more astronomers began to notice an unusual concentration of these nebulae in the constellation Virgo. The real breakthrough in understanding the Virgo cluster came in the 1930s, thanks to the groundbreaking work of Harlow Shapley and Adelaide Ames. Their systematic survey of the region revealed something extraordinary. These weren't just random nebulae, but rather a massive collection of galaxies bound together by gravity. Their 1932 survey, known as the Shapley-Ames Catalog, provided the first comprehensive look at the cluster's structure and distribution of galaxies. The significance of their work cannot be overstated. It helped establish the concept of galaxy clusters as fundamental building blocks of the universe. Their meticulous observations and calculations showed that these galaxies were physically associated with each other, not just coincidentally aligned in our view from Earth. As we move into the modern era, our understanding of the Virgo cluster has expanded dramatically through technological advances that would seem like science fiction to Messier. The Hubble Space Telescope has provided unprecedented views of individual galaxies within the cluster, revealing their intricate structures and interactions. Ground-based observatories equipped with adaptive optics have penetrated the cluster's secrets, while radio telescopes have mapped the invisible gas between galaxies. Perhaps the most spectacular recent achievement came in 2019, when the Event Horizon Telescope captured the first-ever image of a supermassive black hole at the heart of M87, one of the cluster's largest galaxies. This groundbreaking observation not only confirmed theoretical predictions about black holes, but also demonstrated how far our observational capabilities have come since Messier's first glimpses of these cosmic wonders. Modern studies continue to reveal new aspects of the cluster. X-ray observations have mapped the hot gas pervading the space between galaxies, while gravitational lensing studies have helped us understand the distribution of dark matter throughout the cluster. Each new technological advance brings fresh insights into this cosmic metropolis. From Messier's humble catalog to today's network of space-based and ground-based observatories, the story of discovering the Virgo cluster mirrors humanity's journey of cosmic exploration and understanding. It reminds us that each generation builds upon the work of those who came before, gradually unveiling the secrets of our universe. Let's dissect the remarkable anatomy of the Virgo cluster, peering into its structure like cosmic surgeons examining one of the universe's most fascinating specimens. The architecture of this massive galactic gathering tells us a compelling story about the forces that shape our universe. At its heart, the Virgo cluster exhibits a structure that astronomers often compare to a great cosmic city. Just as metropolitan areas have dense downtown regions surrounded by sprawling suburbs, the cluster displays a similar organizational pattern in its galaxy distribution. The cluster's core is an extraordinarily dense region, dominated by massive elliptical galaxies. These cosmic giants are like the skyscrapers of our galactic city, ancient structures that have grown through countless galactic mergers over billions of years. The core region is so densely packed that galaxies here experience frequent close encounters, their gravitational dance altering their shapes and properties over time. As we move outward from this dense core, we find the cluster's outer regions, where the environment becomes less crowded. Here, spiral and irregular galaxies become more common, spreading out like cosmic suburbs. These regions tell a different story, one of younger, more active galaxies still forming stars, their spiral arms glittering with cosmic youth. Unlike their elliptical cousins in the core, these galaxies have managed to maintain their distinctive spiral structures, though many show signs of distortion from the cluster's powerful gravitational influences. Now, let's explore some of the cluster's most remarkable residents. First and foremost is M87, also known as Virgo A, a supergiant elliptical galaxy that serves as the cluster's gravitational monarch. This cosmic behemoth sits near the cluster's center like a massive celestial spider in its web. M87 is famous not only for its size, but also for its spectacular jet of energetic particles, streaming out from its center for thousands of light years. At its heart lies the supermassive black hole that made history as the first ever to be photographed. Moving through our galactic tour, we encounter M84 and M86, two magnificent elliptical galaxies that could be considered M87's cosmic cousins. These giants, while not quite as massive as M87, are still immense structures containing hundreds of billions of stars each. They orbit through the cluster's core region like celestial dancers in a cosmic ballet, their gravitational influence helping to shape the cluster's dynamics. Perhaps most intriguing is M49, which holds the title of being the cluster's brightest galaxy. Despite not being at the cluster's center, M49 outshines even M87 in visible light. This brilliant elliptical galaxy serves as a perfect example of the cluster's ability to nurture the growth of truly massive galactic structures. Its brightness comes from its enormous population of stars, accumulated over billions of years of galactic mergers and interactions. The space between these galactic giants isn't empty either. It's filled with a hot, diffuse gas that creates a kind of cosmic atmosphere throughout the cluster. This intergalactic medium plays a crucial role in the cluster's evolution, affecting how galaxies move, form stars, and interact with each other. Understanding the anatomy of the Virgo cluster is like reading a cosmic history book. Each galaxy, each structure, tells us something about how our universe organizes itself on the grandest scales. From the dense core to the outer regions, from the massive ellipticals to the spiral galaxies, every component adds to our understanding of cosmic evolution and structure formation. Let's journey to the very heart of the Virgo cluster and explore one of the most extraordinary galaxies ever discovered, Messier 87, or M87. This cosmic titan stands as a testament to the extreme phenomena that our universe can produce. M87 is no ordinary galaxy. As a supermassive elliptical galaxy, it dwarfs our Milky Way, spanning a diameter of about 120,000 light-years and containing over 1 trillion stars. Imagine a cosmic giant so massive that it could swallow several galaxies like our own, and you'll begin to grasp the scale of this astronomical colossus. But what truly sets M87 apart is its most dramatic feature, a spectacular relativistic jet that shoots out from its center, stretching an astounding 5,000 light-years into space. This jet, visible in multiple wavelengths of light, is a stream of particles being ejected at nearly the speed of light. It's like a cosmic lighthouse beam, powered by one of the most mysterious objects in the universe, a supermassive black hole. Speaking of which, at the very center of M87 lies a monster that made astronomical history. The galaxy harbors a supermassive black hole with a mass of about 6.5 billion times that of our Sun. Try to imagine an object so dense and massive that it could contain billions of stars like our Sun, all compressed into a region smaller than our solar system. This is the gravitational engine that powers M87's extraordinary phenomena. In 2019, this black hole became an instant celebrity in the scientific world and beyond. The Event Horizon Telescope, a planet-wide network of radio telescopes working in perfect synchronization, accomplished what many thought impossible. It captured the first-ever image of a black hole's shadow. This revolutionary image showed a glowing ring of hot gas orbiting around a dark central region. The event horizon, the point of no return from which not even light can escape. This historic image didn't just give us our first direct look at a black hole. It provided profound validation of Einstein's theory of general relativity and opened a new chapter in our understanding of these cosmic extremes. The image showed exactly what Einstein's equations predicted we would see, confirming theories that had existed only on paper for over a century. The impact on astrophysics was revolutionary. This single image provided unprecedented insights into the behavior of matter and energy under the most extreme conditions in the universe. It allowed scientists to study how black holes interact with their surroundings, how they generate powerful jets, and how they influence the evolution of their host galaxies. M87's black hole continues to be studied intensively, revealing new secrets about the nature of space, time, and gravity. Every observation adds another piece to our understanding of these cosmic behemoths and their role in shaping the universe. Isn't it absolutely mind-blowing? The fact that we can study and even photograph objects billions of light years away, objects so powerful they can bend the very fabric of space-time, shows just how far human ingenuity and technology have brought us in our quest to understand the cosmos. And speaking of amazing discoveries, if you're as awestruck as I am by these cosmic revelations about the Virgo Cluster and M87, show your enthusiasm by hitting that like button. Don't forget to subscribe to Exploring the Universe for more fascinating cosmic explorations. We're on a journey through the most extraordinary phenomena in our universe, and we'd love to have you along for the ride. Enable those notifications, and you won't miss any of our future cosmic adventures as we continue to explore the wonders that space has to offer. Remember, every like and subscription helps us bring these cosmic wonders to more curious minds across our pale blue dot. Together, we're exploring the greatest mysteries our universe has to offer, one discovery at a time. Let's dive into one of the most fascinating aspects of the Virgo Cluster, its incredible dynamics. Imagine a cosmic dance floor where thousands of galaxies move in complex patterns, each following invisible forces that shape their paths through space and time. The movement of galaxies within the Virgo Cluster is nothing short of spectacular. These cosmic giants hurtle through space at mind-boggling speeds, often reaching several hundred kilometers per second. To put this in perspective, at these velocities, a galaxy could travel the distance between Earth and the Moon in just a few minutes. These enormous speeds are a direct result of the cluster's immense gravitational pull, creating a cosmic ballet of unprecedented scale. Within this celestial choreography, galaxies frequently experience close encounters with their neighbors. These cosmic meetings can range from gentle gravitational tugs to dramatic mergers. When galaxies pass close to each other, their mutual gravitational attraction can create stunning effects, stretching out spiral arms, forming bridges of stars between galaxies, and sometimes even tearing smaller galaxies apart in a process astronomers call galactic cannibalism. The frequency of galactic interactions in the Virgo Cluster is particularly high in its dense core. Here, galaxies are packed so closely together that collisions and mergers are almost inevitable over cosmic timescales. These interactions are like cosmic car crashes in slow motion, taking place over millions of years. The result? The gradual transformation of spiral galaxies into elliptical ones, as their elegant spiral structures are disrupted by these gravitational encounters. But there's an even more mysterious force at play in the Virgo Cluster, dark matter. This invisible form of matter, which we can only detect through its gravitational effects, plays a crucial role in holding the entire cluster together. In fact, calculations show that without dark matter, the cluster would fly apart. The visible mass of all its galaxies combined isn't nearly enough to maintain its structure. The evidence for dark matter in the Virgo Cluster is compelling. When astronomers measure the speeds at which galaxies move within the cluster, they find these velocities are far too high for the amount of visible matter present. Something else must be providing the extra gravitational force needed to keep these galaxies bound together, and that something is dark matter. Studies suggest that dark matter forms a massive halo around the entire cluster, like an invisible scaffold that shapes and supports the distribution of visible galaxies. This dark matter halo is estimated to be several times more massive than all the visible matter in the cluster combined. Through sophisticated observations of gravitational lensing, the way gravity bends light, astronomers have even been able to map out the distribution of this invisible matter. The implications of this dark matter dominance are profound. It tells us that what we see in the cluster, all the brilliant galaxies and glowing gas, is just the tip of the cosmic iceberg. The true mass and structure of the cluster is largely invisible to our telescopes, detectable only through its gravitational effects. Understanding the dynamics of the Virgo Cluster isn't just about satisfying scientific curiosity. It provides crucial insights into how galaxy clusters form and evolve throughout the universe. The interplay between visible matter, dark matter, and gravity in the Virgo Cluster serves as a cosmic laboratory, helping us understand the fundamental forces that shape our universe on the largest scales. Moreover, these dynamics affect our own cosmic neighborhood. The Milky Way, along with the entire local group of galaxies, is being inexorably drawn toward the Virgo Cluster by these same gravitational forces. In a sense, we're watching our galaxy's future unfold as we study the cluster's dynamics. The more we study these complex dynamics, the more we realize how interconnected everything is in our cosmic environment. From the dance of galaxies to the invisible hand of dark matter, each aspect plays its part in this grand cosmic performance. Let's explore one of the most fascinating yet often overlooked aspects of the Virgo cluster: the vast ocean of hot gas that fills the space between its galaxies. This intercluster medium, as astronomers call it, is far from empty space. It's a dynamic environment that plays a crucial role in the cluster's evolution. Imagine a cosmic soup heated to extraordinary temperatures, millions of degrees Celsius. That's what fills the space between galaxies in the Virgo cluster. This gas is so hot that it doesn't emit visible light. Instead, it glows brightly in X-rays, revealing its presence to specialized space telescopes like Chandra and XMM Newton. If our eyes could see X-rays, the entire cluster would appear as a vast, glowing cloud with galaxies embedded within it. The temperature of this intercluster medium is truly mind-boggling. At temperatures ranging from 10 to 100 million degrees Celsius, this gas is actually hotter than the surface of most stars. This extreme heat comes from the immense gravitational energy of the cluster, which transforms into thermal energy as gas falls into the cluster's deep gravitational well. But what makes this superhot gas particularly interesting is its profound effect on the cluster's member galaxies. As galaxies move through this medium, they experience what astronomers call ram pressure stripping, a process that's similar to what you might feel if you stuck your hand out of a car window while driving at high speed, but on a vastly larger scale. This ram pressure has dramatic consequences. As galaxies plow through the hot gas at hundreds of kilometers per second, the pressure can literally strip away their own gas reserves. Picture a galaxy moving through this medium like a speedboat creating a wake in water, except in this case, the galaxy is actually losing its own material in the process. The effects of this stripping process are particularly visible in spiral galaxies. These galaxies normally contain significant amounts of cool gas, the fuel needed for forming new stars. As they move through the hot intercluster medium, this precious gas can be stripped away, creating long tails of material trailing behind them. Astronomers have observed several galaxies in the Virgo cluster exhibiting these distinctive features, which they sometimes called jellyfish galaxies due to their appearance. This process has profound implications for galactic evolution. When a galaxy loses its gas reserves, it gradually loses its ability to form new stars. This explains why galaxies in the dense cluster environment tend to be older, redder, and less actively star-forming than their counterparts in less dense regions of space. It's a cosmic case of environment shaping destiny. The intercluster medium also serves as a historical record of the cluster's violent past. The chemical composition of this gas reveals traces of heavy elements that could only have been produced inside stars and then expelled through supernovae explosions. By studying this enriched gas, astronomers can piece together the cluster's history of star formation and galactic interactions. Furthermore, this medium plays a crucial role in the cluster's energy balance. The hot gas can cool and eventually fall toward the cluster's center in what's known as a cooling flow. However, this process is complicated by energy input from active galactic nuclei, particularly the powerful jets from M87's supermassive black hole, which help keep the gas hot and prevent it from cooling too quickly. Recent observations have revealed even more complexity in this intracluster environment. Scientists have discovered subtle temperature variations and metal abundance patterns that provide clues about past merger events and ongoing processes within the cluster. These findings help us understand not just the Virgo cluster, but the general principles governing galaxy cluster evolution throughout the universe. The study of the intercluster medium represents one of the most active areas of research in cluster astronomy. Each new observation with advanced X-ray telescopes reveals more details about this complex environment and its crucial role in galactic evolution. Our story today takes us on a journey that connects our cosmic home, the Milky Way, with the majestic Virgo cluster. It's a tale of gravity, destiny, and the inexorable forces that shape our cosmic neighborhood. Let's begin with our place in this grand cosmic architecture. Our Milky Way galaxy, home to hundreds of billions of stars, actually sits in what we might call the cosmic suburbs. We're part of a smaller group of galaxies called the local group, which in turn resides on the outskirts of something far grander, the local supercluster, also known as the Virgo Supercluster. Think of it as a vast cosmic city, with the Virgo cluster serving as its downtown core, while we occupy a quiet spot in the distant suburbs. But our position in this cosmic landscape isn't static. Right now, as you watch this video, our entire local group is being pulled toward what astronomers call the Great Attractor. This massive gravitational anomaly, which lies in the direction of the Virgo Cluster, is like a cosmic vacuum cleaner, drawing in galaxies and galaxy groups from all around. The Virgo Cluster forms a significant part of this gravitational beacon, its enormous mass helping to shape the movements of countless galaxies, including our own. Our motion toward this cosmic downtown is remarkably fast by human standards. We're traveling at roughly 600 kilometers per second in that direction. But given the vast distances involved, this cosmic journey unfolds over almost unimaginable timescales. It's like watching a glacier move. The process is constant, but requires patience to observe its effects. Now let's peer into the future, the far, far future. Over the next few billion years, the gravitational dance between our local group and the Virgo Cluster will continue to unfold. As we're drawn closer to this massive collection of galaxies, the gravitational influence will grow stronger. The space between us and the cluster will gradually diminish, leading to an eventual cosmic rendezvous that will dramatically reshape our galactic neighborhood. Astronomers predict that in approximately 60 billion years, our local group might finally merge with the Virgo Cluster. Imagine the spectacular sight: thousands of galaxies, including our own Milky Way, coming together in a grand cosmic ballet. During this merger, the space between galaxies will become crowded with interaction and activity. Stars that for billions of years saw only the familiar patterns of our own galaxy will witness new configurations as other galaxies pass nearby. This future merger won't be destructive in the way we might imagine. The vast distances between stars mean that actual collisions between them would be extremely rare. Instead, the merger would be more like a stately dance, with galaxies weaving between each other, their shapes distorted by gravitational forces. Our night sky would gradually transform, filled with the sight of nearby galaxies visible to the naked eye, creating spectacular views that would have been unimaginable to our ancestors. What emerges from this future merger would be a larger, more massive cluster of galaxies. Our Milky Way might eventually lose its beautiful spiral structure, transform through multiple gravitational interactions into an elliptical galaxy, a common fate for galaxies in dense cluster environments. This cosmic future reminds us that even something as vast as our galaxy is just a player in an even grander cosmic drama. The story of our relationship with the Virgo Cluster is still being written across the cosmos, a tale that will continue long after our civilization has passed into history. The movement of our galaxy toward the Virgo Cluster serves as a humbling reminder of our place in the universe. We're not just observers of cosmic events. We're participants in an ongoing cosmic dance that spans billions of years and unfathomable distances. Every moment, we're moving through space as part of this grand celestial choreography, our destiny intertwined with the massive structures that shape our cosmic neighborhood. The Virgo Cluster stands as one of astronomy's most valuable scientific treasures, serving as a natural laboratory that helps us unlock the deepest mysteries of our universe. Its proximity and complexity make it an unparalleled cosmic observatory, offering insights that shape our understanding of the universe's fundamental workings. Imagine having a front-row seat to watch thousands of galaxies interact, collide, and evolve. That's exactly what the Virgo Cluster provides to astronomers. Within its boundaries, we witness galaxy evolution in real time, observing processes that usually take billions of years to unfold. We can see galaxies stripping gas from each other as they pass nearby, creating stunning tales of stars and gas that trace their gravitational interactions. These observations help us understand how galaxies transform from spiral to elliptical shapes, how star formation is triggered or suppressed, and how galaxies grow through mergers and acquisitions. The cluster serves as a perfect laboratory for studying environmental effects on galaxy evolution. As galaxies plunge through the hot, diffuse gas that permeates the cluster, we can observe how this intergalactic medium affects their structure and composition. Some galaxies are literally being stripped of their gas as they move through this cosmic headwind, a process astronomers call ram pressure stripping. This phenomenon creates spectacular scenes where galaxies leave behind trails of gas and stars, like cosmic contrails in the cluster's wake. But perhaps one of the most crucial scientific contributions of the Virgo Cluster lies in its role as a cosmic yardstick. The cluster's relative proximity makes it an invaluable tool for calibrating cosmic distances, a fundamental challenge in astronomy. Think of it as establishing a baseline for measuring the vast distances of the universe, much like surveyors need a known distance to measure unknown ones. Within the cluster, astronomers have identified numerous Cepheid variable stars, cosmic lighthouses whose brightness patterns tell us precise distances. These stars have a remarkable property. Their pulsation period is directly related to their actual brightness. By measuring how bright they appear from Earth and knowing their true brightness, astronomers can calculate their distance with remarkable precision. The Virgo Cluster's Cepheids have become crucial rungs on our cosmic distance ladder, helping us measure distances to galaxies far beyond our local neighborhood. Supernovae within the cluster play an equally important role. Type Ia supernovae in particular are cosmic standard candles, exploding stars that achieve nearly identical peak brightness. When these stellar explosions occur in Virgo Cluster galaxies, they provide independent distance measurements that help verify and refine our cosmic distance scale. These observations are crucial for understanding the expansion rate of the universe and the nature of dark energy. The cluster also serves as a laboratory for studying dark matter, that mysterious substance that makes up most of the universe's mass. By observing how galaxies move within the cluster and analyzing the distortion of light from background galaxies through gravitational lensing, astronomers can map the distribution of dark matter throughout the cluster. These observations provide crucial tests of our theories about how dark matter behaves and influences the evolution of cosmic structures. Moreover, the Virgo Cluster helps us understand how large-scale structures in the universe form and evolve. Its position at the heart of the local supercluster makes it a perfect case study for understanding how gravity assembles galaxies into clusters and clusters into even larger structures. The cluster's complex web of filaments and substructures reveals how matter has flowed and condensed over billions of years, guided by the invisible hand of gravity. The cluster's rich variety of galaxies at different evolutionary stages allows astronomers to piece together the life cycles of galaxies, from young, star-forming spirals to ancient, massive ellipticals. It's like having a cosmic photo album, where we can see galaxies at every stage of their lives, all in one place. This diversity helps us understand how galaxies are born, live, and eventually die or transform through interactions with their environment. The scientific importance of the Virgo Cluster extends even to testing fundamental physics. Its massive black holes, particularly the one in M87, provide laboratories for testing Einstein's theory of general relativity under extreme conditions. The cluster's gravitational effects on light and matter help us verify our understanding of gravity at the largest scales. As our telescopes and instruments become more sophisticated, the Virgo Cluster continues to reveal new secrets. Each discovery adds another piece to our understanding of the cosmic puzzle, from the smallest scales of stellar evolution to the largest structures in the universe. It stands as a testament to the power of astronomical observation and the endless frontiers of human knowledge, reminding us that even our cosmic backyard contains mysteries waiting to be unraveled. Let me take you on a journey through the practical aspects of observing one of the most fascinating celestial structures visible from Earth. Whether you're a complete beginner or an experienced stargazer, the Virgo Cluster offers something for everyone willing to look up at the night sky. Timing is everything when it comes to observing the Virgo Cluster. The prime viewing season runs from March through May, when the constellation Virgo rides high in the evening sky. During these months, the cluster is perfectly positioned for observation, reaching its highest point around midnight in March, 10 p.m. in April, and 8 p.m. in May. This timing isn't just coincidence. It's when the Earth's position in its orbit gives us the clearest view of this region of space, with the cluster visible for many hours during the night. Spring offers another advantage for observers in many parts of the world. The weather tends to be more stable, with fewer clouds and better atmospheric seeing conditions. The moderate temperatures during spring nights also make for more comfortable observing sessions, allowing you to spend more time exploring this celestial wonder. Now, let's talk about what you can actually see. One of the most remarkable aspects of the Virgo Cluster is that several of its galaxies are visible even with modest equipment. On a clear, dark night, away from city lights, good quality binoculars can reveal some of the cluster's brightest members as faint, fuzzy patches of light. The giant elliptical galaxy M87, for instance, appears as a ghostly oval smudge, while M49, the cluster's brightest galaxy, shows up as a more prominent fuzzy spot. For beginners, I recommend starting your exploration with 7 by 50 or 10 by 50 binoculars. These numbers aren't random. The first number indicates magnification, while the second represents the diameter of the front lenses in millimeters. These binoculars offer a good balance between light-gathering power and field of view, making them perfect for scanning the cluster region. When using a telescope, the possibilities expand dramatically. A 4-inch refractor or 6-inch reflector will start to reveal significant detail in the cluster's brighter galaxies. With an 8-inch telescope or larger, you enter the realm of serious galaxy hunting, where dozens of cluster members become visible under dark skies. But observing the Virgo cluster comes with its own unique challenges. The first and perhaps most significant is what astronomers call galaxy hopping. Unlike bright stars or planets, these galaxies are subtle objects that require patience and technique to locate. I recommend starting with the bright star Vendemiatrix in Virgo, then slowly scanning the area westward. Create a mental map of star patterns that will help you navigate from one galaxy to another. For digital assistance, several astronomy apps can help you locate cluster members. These apps can overlay star charts with galaxy positions, making navigation much easier. However, I encourage you to learn the old-school star-hopping techniques as well. There's something deeply satisfying about finding these distant objects using just your knowledge of the sky. Remember that patience is key when observing the Virgo cluster. Take time to let your eyes dark adapt, usually 30 minutes or more. Make your observations systematic, working through different sections of the cluster methodically. Sometimes, a galaxy that's invisible at first glance will slowly materialize after several minutes of careful observation. Whether you're using binoculars, a telescope, or a camera, observing the Virgo cluster connects you directly with some of the most massive and magnificent structures in our cosmic neighborhood. Each faint smudge of light you see represents billions of stars, and as you observe, you're looking back through millions of years of cosmic time. It's a humbling and inspiring experience that rewards every observer who takes the time to explore this remarkable region of our night sky. As we stand on the threshold of a new era in astronomy, the Virgo cluster continues to beckon scientists with its unexplored mysteries and untold stories. The coming decades promise revolutionary discoveries that will transform our understanding of this cosmic metropolis, powered by next-generation observatories and cutting-edge technologies. Let's begin with the James Webb Space Telescope, humanity's most powerful eye in the sky. This remarkable observatory's infrared vision penetrates the cosmic dust that often obscures our view of the Virgo cluster's galaxies. Webb's unprecedented sensitivity and resolution are revealing the cluster's galaxies in extraordinary detail, showing us the intricate dance of star formation and galaxy evolution with clarity we've never before achieved. Webb's observations are particularly exciting because they allow us to peer into the hearts of galaxies where stars are being born. Its infrared capabilities cut through the dust lanes that typically hide these stellar nurseries, giving us front-row seats to witness the birth of new stars within the cluster's galaxies. This information is crucial for understanding how the cluster environment influences star formation and galaxy evolution. Another game-changing facility is the Vera C. Rubin Observatory, formerly known as the Large Synoptic Survey Telescope. This revolutionary observatory will conduct the legacy survey of space and time, creating the most detailed map ever of the southern sky. When it comes to the Virgo cluster, the Rubin Observatory will track subtle changes in galaxies over time, potentially capturing transient events like supernovae and stellar mergers within cluster galaxies. The Rubin Observatory's massive survey will also help us better understand the cluster's three-dimensional structure. By measuring the precise positions and movements of thousands of galaxies, we'll create the most accurate map yet of how matter is distributed throughout the cluster. This information is crucial for understanding the cluster's gravitational dynamics and its future evolution. But perhaps the most intriguing questions about the Virgo cluster concern dark matter, that mysterious substance that makes up most of the cluster's mass. Future observations using gravitational lensing techniques will help create increasingly detailed maps of dark matter distribution within the cluster. Combined with observations of visible matter, these maps will help us understand how dark matter shapes the cluster's structure and influences its evolution. Advanced computer simulations will play an increasingly important role in our research. As computing power grows, we can create more sophisticated models of the cluster's evolution, tracking the complex interactions between thousands of galaxies over billions of years. These simulations will help us predict the cluster's future and better understand its past, including how it assembled into the structure we see today. Looking further ahead, proposed space telescopes with even greater capabilities than Webb could revolutionize our understanding of the cluster. These future observatories might use new technologies we can only dream of today, perhaps including arrays of telescopes working together to create virtual instruments the size of Earth's orbit. One of the most exciting prospects is the potential for discovering new types of astronomical phenomena within the cluster. As our detection capabilities improve, we might find evidence of exotic objects or processes we haven't yet imagined. The dense environment of the cluster makes it an ideal laboratory for discovering rare cosmic events that occur when galaxies and their components interact. The evolution of the cluster itself remains a fascinating area for future research. How will the ongoing infall of galaxies affect its structure? Will the cluster continue to grow indefinitely, or will dark energy eventually halt its growth? These questions touch on fundamental issues in cosmology and physics that future observations may help resolve. Researchers are particularly interested in understanding how the cluster's hot intergalactic medium evolves. This superheated gas, visible primarily in X-rays, plays a crucial role in galaxy evolution, but many aspects of its behavior remain mysterious. Future X-ray observatories will help us better understand how this gas influences galaxy formation and evolution within the cluster. The relationship between supermassive black holes and their host galaxies within the cluster is another frontier for future research. We're discovering that these cosmic behemoths play a crucial role in regulating galaxy evolution, but the details of this relationship are still being worked out. Future observations will help us understand how black holes influence their galaxies and the surrounding cluster environment. We're also on the verge of better understanding the cluster's role in cosmic ray production. The violent processes within cluster galaxies and the intergalactic medium accelerate particles to enormous energies, but the exact mechanisms remain unclear. Future observations across multiple wavelengths will help us piece together this high-energy puzzle. Perhaps most excitingly, we're developing new tools to study gravitational waves emanating from events within the cluster. As our gravitational wave detectors become more sensitive, we might detect signals from merging black holes or neutron stars within cluster galaxies, adding another dimension to our understanding of this cosmic metropolis. As we look to the future, it's clear that the Virgo Cluster will continue to be a cornerstone of astronomical research. Each new generation of instruments and observatories promises to reveal new layers of complexity in this cosmic structure, helping us better understand not just the cluster itself, but the fundamental principles that govern our universe. The coming decades promise to be an exciting time of discovery as we continue to unravel the mysteries of this remarkable cosmic neighborhood. As we conclude our cosmic journey through the Virgo Cluster, let's take a moment to reflect on the profound significance of this celestial marvel. What appears to our eyes as mere smudges of light against the dark canvas of space represents one of the most dynamic and enlightening natural laboratories in our cosmic neighborhood. The Virgo Cluster stands as a testament to the incredible complexity and beauty of our universe. Within its vast expanse, we find a living, breathing ecosystem of galaxies, where cosmic giants dance in an eternal gravitational ballet. From its supermassive black holes, each containing the mass of billions of suns, to the vast oceans of superheated gas that fill the space between galaxies, every aspect of the cluster tells a story of cosmic evolution and transformation. This massive collection of galaxies has become our window into understanding the fundamental workings of the universe. Through studying the Virgo Cluster, we've gained invaluable insights into how galaxies form, evolve, and interact. We've learned about the mysterious influence of dark matter, witnessed the power of supermassive black holes, and begun to understand the complex interplay between galaxies and their environment. But perhaps most humbling is the perspective the cluster gives us about our own place in the cosmos. Our Milky Way, home to hundreds of billions of stars and countless worlds, is but a modest spiral galaxy in the cosmic suburbs, slowly being drawn toward this mighty collection of galaxies. This reminder of our cosmic context serves to both humble and inspire us, showcasing the grandeur of the universe while highlighting the remarkable achievement of human intelligence in comprehending these distant realms. As our technology advances and our understanding deepens, the Virgo Cluster continues to surprise us with new discoveries. Each observation reveals new layers of complexity. Each study uncovers new mysteries to solve. It stands as an inexhaustible source of scientific wonder, promising countless discoveries for generations of astronomers to come. Your journey through the cosmos continues. If this exploration of the Virgo Cluster has ignited your passion for the cosmos, your journey doesn't need to end here. The universe is filled with countless wonders waiting to be discovered, and we're here to guide you through them all on exploring the universe. By subscribing to our channel, you'll join a community of cosmic explorers, embarking on regular journeys from the familiar planets of our solar system to the most distant galaxies ever observed. Each video is crafted to bring you not just information, but a sense of wonder and connection to the vast cosmos we call home. Share this video with fellow astronomy enthusiasts, or anyone who's ever looked up at the night sky with curiosity. Your likes and comments help us create better content and build a stronger community of space explorers. Plus, don't forget to hit that notification bell to stay updated on our latest cosmic adventures. Remember, every time you look up at the night sky, you're not just seeing random points of light, you're witnessing the grand cosmic dance of the universe itself. And somewhere out there, the Virgo Cluster continues its eternal waltz, a beacon of discovery for generations of astronomers to come. Until our next journey among the stars, keep exploring, keep wondering, and keep looking up. The universe is waiting for you, and there's always more to discover on exploring the universe. This is your cosmic guide, signing off until our next adventure through the wonders of space. Clear skies, and see you among the stars.